Okay, we're going to look at a new topic which is called polynomials, and within that the first lesson that we're going to explore is factor theorem. Okay, now if we can just concentrate first of all on the word polynomials. Well, what you can take from polynomials is the prefix of poly. Poly just means many. Now, what that means in this context is you would call something like 4x plus 1 a linear function. Okay, you would call something like 4x plus 2 a quadratic function. So linear meaning that it behaves like a straight line if you sketch it. Quadratic meaning that it behaves like a parabola. Now what you get beyond that is things that have got to the power 5, power 3, might be power 4, power 3. Now when you've got a collection of powers above a degree of 2 in a equation, you collect all them together and say that that's of many polynomials, and that's where it comes from. Okay, factor theorem being the first lesson. So remember that if something's a factor, it leaves no remainder, so it would be a 0 remainder. Now what we're going to learn to do is to factorise not linear functions, that's national 4, not quadratic functions, that's national 5, but we're going to learn to factorise polynomials by using something called synthetic division that I'll talk about in a second. Okay, now probably best explained by just getting straight into an example, so let's go for an example 1. Okay, so example 1, we're going to show that x minus 4 is a factor of 2x to the power 4 minus 9x cubed plus 5x squared minus 3x minus 4. Okay, now just go away with this one. There's a trick for doing this, and we set up this thing called synthetic division, which is this table. Now to get going with this, what you do is you put in your coefficients in front of each of the variables. Okay, so we start with a coefficient of 2 that's attached to the x to the power 4, and then a coefficient of minus 9, and then a coefficient of 5, minus 3, and then finally minus 4. Okay, now just follow a pattern with this one. What we next do is look to put a number up at the side. Now, if you think about if x minus 4 is a factor, well, if you've got x minus 4 as a factor next to a collection of other brackets, that means when you solve the thing to be equal to 0, you'll get x minus 4 equals 0, and that means that the factor occurred when x equals 4. So in essence what we do is bring across the equal sign, and that x minus 4 becomes 4. That's the number that goes up at the side. Okay. Now, take a wee note of this for one time only. We call that the divisor. So that's the thing that we divide by. Okay. Next move is that 2 that you started with, you drop it down there and put it there. You just follow this pattern. You then get the 2 and you multiply it by the number upside here, which is 4. 2 times 4 is 8. And then what you do is put that 8 up there. You then add these together. 8 minus 9 is minus 1. You then get that minus 1 and you multiply it again by the 4. And that will give me minus 4, and you put that up there. You add these together again. Minus 4 plus 5 is 1. And you repeat the process, so it's now going to be 1 multiplied by 4. 1 multiplied by 4 is 4. 4 minus 3 is 1. Follow the pattern again. 1 times 4 is 4. And then 4 minus 4 is 0. Okay, now this bit we call the remainder. Now, since the remainder is equal to 0, we know that it's a factor. So what I'm going to say here is 0 equals r i.e. the remainder equals 0. Therefore, x minus 4 is a factor. At that point, we call this the result of division, which is, you'll have heard this before at some point, that's called the quotient. Okay, so let's just go over this process again. I'm going to show that x minus 4 is a factor. Now, if x minus 4 is a factor, that means when you're solving, making the thing equal to 0, x minus 4 is equal to 0 and x is equal to 4. The number goes up as 4. We then put our coefficients of the polynomial down. So that's going to be 2, minus 9, 5, minus 3, minus 4. We then drop the 2 down. 2 times 4 is 8. 8 minus 9 is minus 1. Minus 1 times 4 is minus 4. Minus 4 plus 5 is 1. 1 times 4 is 4. 4 minus 3 is 1. 1 times 4 is 4. And 4 minus 4 is 0. The bit at the end is the remainder. The remainder is 0. Therefore, the thing needs to be a factor. Now, another point to say is, since the question says show that, I need to back it up with a statement, which is right there. Let's try an example 2. Okay, we're going to show that, example 2, we're going to show that 2x minus 1 is a factor of 2x cubed plus x squared minus 5x plus 2. Okay, first move, let's get the table drawn. Okay, coefficients 2, 1, minus 5, 2. Okay, drop the 2 down. What number goes up at the side? Let's have a think about it. Well, if 2x minus 1 is a factor, so that could be an example of that. We would have 2x minus 1 is equal to 0. 2x would be equal to 1 and x would be 1 half. So the number that goes up at the side then is a half. Okay, I'll drop the 2 down. It's then 2 times a half is 1. 1 plus 1 is 2. 2 times a half is 1. 1 minus 5 is minus 4. Minus 4 times a half is minus 2. 2 minus 2 is 0. R equals 0. Therefore, 2x minus 1 is a factor. Okay, let's try an example 3. Okay, example 3, we're going to show that x plus 1 is a factor of x cubed minus 7x minus 6. Okay, so let's get the table drawn and look at our coefficients. Okay, so the coefficients then are going to be 1, minus 7 and minus 6. At that point, I'm going to just put a line through that because that's not correct. It's tempting to go for that, but that's definitely not correct. Now, what we need to do here is to include 0 coefficients. Now, what does that mean? Well, if you think about x cubed minus 7x minus 6, well, that's the same as x cubed plus 0x squared minus 7x minus 6. The point being is, if I'm going to move between the cubic to the linear bit, there is a quadratic bit that's in between, but it just so happens if it's not there, I need to record it as a 0 coefficient. Okay, so I need to go from degree 3 down to degree 2, then degree 1, and then degree 0. But I need to record, if there's not an x squared term there, I need to record it as a 0x squared term. But that needs to be recorded within the table. So the table, in fact, should look like this. common factor of one coefficient, rather 1x cubed, 0x squared, minus 7, and then minus 6. Drop the 1 down. Okay, so x plus 1 is a factor, which means if to solve it, then x would be minus 1. Okay. Drop the 1 down. 1 times minus 1 is minus 1, 0 minus 1 is minus 1. Minus 1 times minus 1 is 1. 1 minus 7 is minus 6. Minus 6 times minus 1 is 6. 6 minus 6 is 0. R equals 0. Therefore, x plus 1 is a factor. And I back up a statement since the question did say show that. Okay, now this time I'm going to do something extra, which is going to be worth a few more marks. I'm going to factorise the thing fully. Okay, so I've proven that x plus 1 is a factor. I'm now going to go ahead and factorise the thing fully. Now, first thing, I know that there must be first of all a bracket x plus 1, because that was shown early in the question. Show that x plus 1 is a factor. It is a factor, therefore that's something that I can put in brackets. Now, I need to think about algebraically what this would look like. That's quite straightforward. You start at the end, that's going to be minus 6, that's going to be minus x, and that's going to be x squared. So that term then is x squared minus x minus 6. Let's write that down beside it. X squared minus x minus 6. Two numbers that multiply give minus 6, add together give minus 1, that's minus 3 and 2, and that is the thing fully factorised. Okay, next one. Show that 3x plus 1 is a factor of 3x cubed plus 4x squared minus 5x minus 2, and hence factorise fully. Okay, first of all, what number goes up at the side? Well, 3x plus 1 is a factor, which means when I solve it, 3x equals minus 1 and x equals minus 1 over 3, that's the number up at the side. Okay, what's my coefficients? 3, 4, minus 5, minus 2. This time there's no 0 coefficient. 3, 4, minus 5, minus 2. Drop 3 down. 3 times minus a third is minus 1. Minus 1 plus 4 is 3. 3 times minus a third is minus 1. Minus 1 minus 5 is minus 6. Minus 6 times minus a third is plus 2. 2 minus 2 is 0. R equals 0. Therefore, 3x plus 1 is a factor. Okay, so what's this bit here then? That's now 3x squared minus 3x minus 6. And that side I've got 3x plus 1. Okay, now what I can do next is to take out a common factor there. 3 bracket x squared minus x minus 2. Two numbers that multiply give minus 2, add together give minus 1. That's going to be plus 1 and minus 2. Final move I can make then is just to put the 3 at the front. That would look a bit better. And that would finish it off to look like this 3 bracket 3x plus 1 bracket x plus 1 bracket x minus 2.